Hello, my dear students. Let us take some more examples on bearing capacity of soil. A rectangular footing, 2 meter by 3 meter, rests on a C5 soil with its base at 1.5 meter below the ground surface. Calculate the safe bearing capacity using a factor of safety of 3. First one is net ultimate bearing capacity and second one ultimate bearing capacity. The soil has following parameters: gamma is equal to 18 kilonewton per meter cube, C is equal to 10 kilonewton per meter square, and phi is equal to 30 degree. Use Desargues analysis. So here it is asked to calculate what is the net ultimate bearing capacity, and you have to calculate safe bearing capacity using a factor of safety, first for net ultimate bearing capacity and other one the safe bearing capacity for ultimate bearing capacity. Okay, so here for the rectangular footing for C5 soil, the formula is this one: QF ultimate bearing capacity is equal to C into NC into 1 plus 0.3 into B divided by L plus gamma into D into N cube plus 0.5 gamma into B into N gamma into 1 minus 0.2 B divided by L. This is a formula for rectangular footing. Now phi is equal to 30 degree. Here it is not mentioned whether local shear failure or general shear failure. So I consider general shear failure. Okay. So take the values for 30 degree. NC is equal to 37.2, NQ is equal to 22.5 and N gamma is 19.7. This is on using the table. Now you have to calculate what is ultimate bearing capacity. QF is equal to, substitute in this equation, C equal to 10 and NC is 37.2 into 1 plus 0.3. B is 2 meter and D is, L is 3 meter plus second term 18 gamma into D, depth of the foundation 1.5 into N cube 22.5 plus 0.5 into gamma is 18 into B, that is 2 meter, into N gamma, that is 19.7 into 1 minus 0.2 times of B divided by L. B is 2 and L is 3 meter. Simplify this, we'll get QF is equal to 1361.2 kilonewton per meter square. We have to calculate safe bearing capacity. To find safe bearing capacity, you have to calculate first net bearing capacity. So net bearing capacity, that is equal to ultimate bearing capacity minus this gamma D over burden pressure. So that is QF minus gamma D. Substitute the value of QF, that is 1361.2 minus gamma is 18 into D 1.5. We will get 1334.2 kilonewton per meter square. Now you have to calculate what is safe bearing capacity. That is nothing but divided by factor of safety, net ultimate bearing capacity divided by factor of safety plus gamma D. So we will get 471.7 kilonewton per meter square. This is for the first case. Okay, net ultimate bearing capacity. Now we have to calculate for ultimate bearing capacity. That is nothing but just divided by factor of safety. That's it. Okay, so ultimate bearing capacity, that is this value 1361.2 divided by factor of safety, that is divided by 3, we will get 453.7 kilonewton per meter square. Very simple. Just you have to calculate safe bearing capacity for the two conditions. First condition is net ultimate bearing capacity and second condition is for ultimate bearing capacity. So just divide the whatever the value you get divided by factor of safety. Okay, we'll take one more problem. A square footing located at a depth of 1.3 meter below the ground has to carry a safe load of 800 kilonewton. Find the size of the footing if the desired factor of safety is 3. The soil has the following properties. Void ratio is 0.55, degree of saturation is 50%, specific gravity is 2.67 and C is equal to 8 kilonewton per meter square, phi is equal to 30 degree, and use the Terzaghi's analysis. Here gamma value is not given, so you have to calculate gamma value using these properties of soil. Okay, now this is a square footing, right? And here it is not asked which type of failure, so let us consider general shear failure. Now, how to calculate gamma? All of you know this formula. You have studied in the first unit, index properties of soil. So, gamma is equal to G plus SE into gamma W divided by 1 plus E. G is given 2.67 specific gravity plus E is void ratio 0.55 into S, degree of saturation is 50%, so 0.5 into gamma W is 9.81 divided by 1 plus E. E is equal to 0.55. So we will get 18.64 kilonewton per meter cube. So now you know what is gamma value. You have phi value. So based on the phi value, using the table, you can get what are the values for NC, NQ, and gamma. For Terzaghi's bearing capacity equation for the square footing is given by, this is the formula, QF is equal to 1.3 CNC plus gamma D NQ plus 0.4 gamma B N gamma. Okay, here I have directly told sigma dash, that is equal to gamma D. Okay, so substitute all the values. You have everything here. 1.3 into C, C is 8 into NC, that is 7.2 plus 0.4 into gamma is 18.64 into B is 1.3 meter into gamma, N gamma, that is 20, NQ, that is 22.5 plus 0.4 into 18.64 into B, we don't know, we have to calculate the size of the footing it is asked, so that let it be B only into what is N gamma 19.7. So whatever the answer you get in terms of B, so this you cannot add it here, the two terms, two terms you can add, these two, gamma into D, but this term you cannot add because there is B. Okay, so you get this answer. Now we know QNF, net ultimate bearing capacity, that is equal to ultimate bearing capacity minus gamma into D. So substitute this value, let it be like this, minus gamma is 18.64 into D, depth of the foundation is given 1.3. So you get this answer. Now what is safe bearing capacity? Safe bearing capacity is equal to QNF divided by factor of safety plus gamma D. QNF, that is equal to 907.87 plus 146.88 B divided by F. F is given 3 plus gamma into D. Gamma is 18.64, calculated value, into D is 1.3. So we will get QS equal to 326.86 plus 48.96 B kilonewton per meter square. Now what we have to calculate? We have to find the size of the footing. Okay, now all of us know here what is given, load is given, right? Carry a safe load of 800 kilonewton. We know intensity is equal to load divided by area. How it is? Stress is equal to load divided by area. Okay, here it is written in terms of intensity, so load divided by area. QA, this is the actual load. Load is given, that is 800 kilonewton divided by area. This is a square footing, so area is B into B, that is B square. Now we have the what is safe bearing capacity. So that equate this and this value. So that is 800 divided by B square, that is equal to this value. Okay, 326.86 plus 48.96 B. So only one unknown. This is why know that factor of safety is equal to actually the load bearing capacity divided by the actual load bearing capacity. So based on that one only, we can assume that this equation, this is equal to this net bearing capacity is equal to the actual load intensity, because we have considered the factor of safety and it is multiplied by this QS. Okay, so now when you simplify this, you will get B is equal to B square, or B is equal to is equal to 16.34. So now only one method to calculate B is trial and error method. Substitute different values for B. One when this two becomes equal, take that value for B. So you can start with 1. If you substitute B is equal to 1, you get 1 cube, 1 plus 1 6.676. So that is not correct. So here this is 16.34 when simplified. So again like that, substitute different value. Once if you substitute 1.42, that is equal to, when LHS left side is equal to right side. Okay, so you try this, you have to get the answer B is equal to 1.42 meter. I hope all of you understood. Let us take one more example on circular footing. Same type of problem. Determine the depth at which a circular footing of 2 meter diameter be founded to provide a factor of safety of 3 if it has to carry a safe load of 1600 kilonewton. The foundation soil has C is equal to 10 kilonewton per meter square, phi is equal to 30 degree, and unit weight is equal to 18 kilonewton per meter cube. Use Terzaghi's analysis. Okay, here again everything is same, only the difference is circular footing. Okay, so phi is equal to 30 degree. So take assume general shear failure value. So NC is equal to 37.2, NQ is 22.5, and gamma is 19.7. Here gamma value is given, so that is 18 kilonewton per meter cube. Okay, now first find the ultimate bearing capacity, or you can find net ultimate bearing capacity in one single step. That means you have to consider this formula now. This type of problem I have solved in the first class. Okay, any method you can use. You can use directly QF formula and then you can find QNF, or this also you can use. Okay, if we use QNF is equal to 1.3 CNS NC plus gamma D NQ minus 1 plus 0.3 N gamma into P into N gamma. Okay, substitute all the values. We have everything. Only the unknown is here. Depth of the foundation, that is not given. Okay, gamma into D, that we have to calculate here. Then everything is there. B is nothing but here this is the diameter. Okay, in this case this is a circular footing, so you have to consider B is equal to 2 meter, diameter is 2. So simplify this, you will get 696.36 plus 387 D. Okay, now safe bearing capacity, already net bearing capacity is found out. Directly you can calculate safe bearing capacity, that is QNF divided by F plus gamma D. Simplify, substitute QNF value 696.36 plus 387 D divided by factor of safety is 3 plus gamma into D. Gamma is 18. D we don't know. So simplify this, you get QS is equal to 232.12 plus 147 D. Now same method we have to use the load intensity. Here the load is given, safe load is 1600 kilonewton. So convert into intensity. What you have to do? Divided by area. This is a circular footing, so area is pi by 4 D square. So D is here 2 square. Okay, so equal to 509.3. Now equate this QA with the QS. So what happens? QS is 232.12 plus 147D, that is equal to 509.3. So only one unknown, D. So we will get D is equal to 1.89 meter. So you can consider D is equal to 1.9 meter. Okay, I hope all of you understood. Thank you. Let us take one more example on stiff footing. Okay, design a stiff footing to carry a load of 750 kilonewton per meter at a depth of 1.6 meter in a C5 soil having a unit weight of 18 kilonewton per meter cube and shear strength parameters as C is equal to 20 kilonewton per meter square and phi is equal to 25 degree. Determine the width of the footing using a factor of safety of 3 against shear failure used as a GIS equations. Okay, here also asked to calculate design a stiff footing means you have to find the size of the footing. This is a stiff footing, so you have to calculate what is B. Okay, so it is given that 750 kilonewton per meter length. Okay, per meter length it is given. So you can find what is the size of the footing. That is nothing but B. Okay, so let us assume general shear failure, and and this is a stiff footing. So formula is QF is equal to CNC plus sigma dash or gamma D NQ plus 0.5 gamma beta N gamma. Right, so here take NC, NQ and gamma values from the table. For phi is equal to 25 degree. So you will get NC is equal to 25.1, NQ is 12.7 and N gamma is 9.7. Now substitute all the values in this equation. So we will get QF, ultimate bearing capacity, is equal to 20 into NC is 25.1 plus gamma sigma dash is nothing but gamma into D. Gamma is 18 into D. D is 1.6 into NQ, that is 12.7 plus 0.5 into gamma is 18 into B into 9.7. B is the unknown. Okay, simplify this. We will get 867.8 plus 87.3 B. Next, you have to calculate net ultimate bearing capacity. That is nothing but QF minus gamma D. So QF is 867.8 plus 87.3 B minus gamma D, that is 18 into 1.6. So we will get 839 minus 87.3 B. Now you have to calculate what is safe bearing capacity, that is QS, that is equal to QNF divided by factor of safety plus gamma D. Okay, so QNF is 839 minus 87.3 divided by factor of safety is 3 plus gamma D is 1.6 into 18, 28.8. So now this is QS, safe bearing capacity. Now we have load intensity. We can calculate how it is. That is nothing but the load divided by area, that gives the intensity. Now here load is given, that is 750 kilonewton per meter, means per meter width it is. So that is 750. Area is here stiff footing, that is B into 1. Okay, for 1 meter length. So B into 1, that is equal to 750 divided by B. Okay, so that is in kilonewton per meter square. So now both are in kilonewton per meter square. Both becomes intensity. Before it was load. So when you divide it by area, that is the stiff footing is B into 1 meter length. So that is area. So you will get 750 divided by B kilonewton per meter square. Now you can equate this. QS is equal to QA, applied load intensity. So that is nothing but 750 divided by B is equal to, simplify this, okay, 839 divided by 3, minus 87.3 be divided by 3 plus 28.8, we will get this. Okay, now cross multiply this. 750 is equal to 308.76 b minus 29.1 b square. How we can calculate? By trial and error, substitute the different values of b. Once the right side is equal to left side value, then you can take that as the value for b. So when you substitute b is equal to 2.134, this equation satisfies, means right side is equal to left side. So we can take b is equal to 2.134. So I have now done for different types shapes of footing how to calculate the size. Okay, I think all of you now understood for rectangular footing and for square footing, for circular footing and strip footing. So whenever the load is given, you have to convert into area, stress. The load divided by area is stress. In this case, it is calculated as bearing capacity. So once it is converted into intensity, you can equate with the bearing capacity values, that is safe bearing capacity value. Once if you equate, only one unknown will be there, so you can easily find what is the size of the different types of footing. I hope all of you understood. Thank you.